Hello and welcome back to my YouTube channel. Today we are going to see Class 8 Science chapter number 7 Metals and Nonmetals part 2. In part 1 already we have discussed about the metals and nonmetals and their physical properties. The properties they possess, the physical properties like physical state, luster, brittleness, ductility, malleability, melting point, boiling point. Means this physical properties already we have discussed regarding the metals and non-metals. Today we are going to move towards the chemical properties for the metals and non-metals. So I'm just beginning with the chemical properties of the metals. In that, the first what we have to study is electronic configuration. Electronic configuration is nothing but on the basis of which we can talk about the chemical properties or the chemical behavior of an element. Electronic configuration is a division of electrons in a different shells present in an atom, which already we have studied in the previous chapters. When we talk about the metals generally they have up to 3 electrons, means they can have 1, 2, 3. Most of the metals they have these number of electrons, 1, 2 or 3, the outermost orbit or the outermost shell. And due to that, these metals when we talk about, they are capable to donate the electron in the bond formations. If you will observe over here, sodium, magnesium and aluminium, they are having 1, 2 and 3 respectively. Now here the further when we talk about the another property, formation of ions. As just now I talked about that metals can easily donate the electrons, and after donating electrons they are forming a charged ions, a positive charged ions, because if the negative charged electrons are coming out or donated by the atoms, then definitely they will form the positive charge on the ions. Now example they have given over here of the sodium, magnesium and aluminium, all the three they have given. If you will see the sodium 281, after donating one electron, this one electron sodium is donating or transferring to the some other atom, and if one of the negative charge goes out, then definitely a positive charge will be more in the atom. Simply, if I am talking about the sodium, there are 11 protons and 11 electrons. After giving out one electron, there will be only a 10 electrons, means 10 negative and 11 positive, means one positive is extra, and that's why here if you will see the sodium is gaining a 1 plus charge. It will be much clearer when we'll see the next example. See the magnesium. Magnesium's electronic configuration is 282. It's donating or giving this 2 electrons, and that's why the magnesium is having 2 plus, because now 2 positive charged protons are more in the atom of the magnesium ion. In the aluminium 3 are there, so it's giving 3 electrons and gaining a 3 plus charge. So this is about formation of ions in metals. Next chemical property what we have to see is a reaction with oxygen. Whenever we talk about the metals and they are reacting with the oxygen and forming a metal oxide. Metals combine with oxygen to form their oxides. If sodium is reacting with the oxygen, it will form a sodium oxide. Magnesium with the oxygen, magnesium oxide. Like this, they are forming the oxide. And these oxides of the metals, when they are reacting with the acids, it's forming the acid and water. Sorry, not acid. Acids are reacting with the metal oxide, then it forms the salt and water. This is about reaction with the oxygen. Now the further is reaction with acid. When metals are reacting with the acids, they are forming the salt, and along with that the hydrogen gas is liberated. You can see here they have given the general equation, that is metal reacting with the dilute acid forming the salt plus hydrogen gas. Salt of that metal will be liberated or produced, and along with that the hydrogen gas H2 gas will be released. Further, when we talk about the metals reacting with the water, then most of the metals do not show any observable and fast reaction with the cold water. Means they don't have the quick or the fast reaction with the water. Maximum of the metals are like that, but some metals like a sodium and a potassium, they react with the cold water to produce their hydroxides and hydrogen gas. Magnesium metal requires a steam to give similar reactions, and magnesium requires a steam, the hot water it requires. Then only the reaction can occur. Next is about the chemical properties of the nonmetals. When we talk about the nonmetals, their electronic configuration, they have a shortage of electron in the outermost orbit for the duplet or octet. Like here, when we talk about, you can see 5, 6, 7. This is a general number of electrons what they are having in their outermost orbit or the outermost shell. So 4 to 7 electrons you can find in the non-metals atom in their outermost shell. Here they have taken the example of the nitrogen, oxygen and chlorine. Their atomic numbers are 7, 8 and 17. And these non-metals, when we talk about, they accept the electron which was donated by the metals, and they forms a negative charged ions. Because here if you will see the examples they have taken as a chlorine, and one electron is accepting, so electronic configuration 287 converts into 288, and the negative charged ion of a chlorine is formed. Oxygen accepts 2, so here 2 minuses there. If nitrogen, then it's accept 3 electrons, then it forms a nitrogen 3 minus, because here what happens the same way, the number of proton is less and the number of electron is more. In chlorine we have the 17 proton and 18 electron, and that's why the 1 minus. Further is reaction with oxygen. Non-metals combine with oxygen to form their oxides. Like metals are reacting with the oxygen and forming a metal oxide, so here non-metal reacting with the oxygen and forming a non-metal oxide. The oxides of a non-metals are acidic in nature. The important term they have given over here, the oxides of non-metals are acidic in nature. They react with bases to form soluble salt and water. When we talk about the metals, there it reacts with the acid to form the salt and water, whereas here it forms a salt and water, but after reacting with the bases. Further, they have given these some more examples for this. You can see then the non-metals do not react with dilute acids. They don't react with the dilute acids. Now the next what we have to study is the uses of metals and non-metals. Now this table is an assignment number 2 which you have to complete and send me in the Google Classroom. This is as an assignment for you. This particular table, only what you have to do, I'm just giving you a hint what exactly you are supposed to do. When you are at your home, just observe the objects or the articles or the materials kept in your surrounding. It can be anything. You have to write the name of a metal used in that particular article and what is the use. of that particular article that you have to write. Okay. Now, for the noble metal, till here we studied metals and their reactions with the different kind of the elements or the compounds, like metals reacting with acid, then non-metals reacting with the bases, metal reacting with oxygen, water, like that different we have studied. There are the certain metals which are less reactive and they are found in the elemental state in the nature, means they are found in a free way in the nature, means they are not found in the compound form, they don't react actively with the others. So that's why they are called as the noble metals, and they are just like gold, silver, platinum, palladium, and rhodium. They are called as the noble metals. They occur in a nature in an elemental state. Gold, which is 100% pure, is called as a 24 karat gold. And that's why when we talk about the gold ornaments, then the goldsmiths, what they are doing, they are adding these some impurities. Impurities means some other metals they are mixing and making it hard, because the pure gold what we are having, it's very soft and easily it can bend. So to give it a proper shape and structure in the ornaments, some impurities or some extra metals are added in the pure gold. Some more uses we have for the noble metals, in that the one is gold, silver, and platinum. They are used to prepare ornaments. Silver used in a medicine. Gold and silver also used to make medals. Gold and silver also used to make few electronic devices. Platinum, palladium metals are used as catalyst. Now the purity of the gold, how to find out the purity of a gold? It's simply what we have to do. If we are talking about the carats of the gold, then that we have to divide by 24, because 24 carat is considered as 100%. Suppose if I am talking about 18 karat gold, then 18 upon 24 into 100. Whatever result you will be getting in this, that will be the percentage of the pure gold in that particular sample of a gold. Because gold in that various peoples are adding the impurities, they are reducing the purity of a gold by adding the some other metals. So if they are saying it as a 18 karat, then there should be this particular percentage of gold should be there. Like here, if you will calculate, you will be getting a 75%. Means if you are having 100 gram of a gold, which if it is labeled as a 18 karat, then in that 100 grams, 75 grams will be the pure gold. So this is a way how to calculate the amount of a pure gold present in a different labeled golds. Further, when we talk about the corrosion, now gases in the air react with metals in presence of a moisture to form metal compounds. The most important part. If you might have observed that at your home, that if we are having a copper vessel or the copper pot and we are leaving it in a open for a while, or for 1 day or 2 day, then the color of that copper pot changes. Not only that, uh, other metal articles also, iron, especially the iron nail, when we keep at our home, what happened after a few days, the color of iron nail changes. Not only changes, along with that, some dark layer get formed on the iron nail, and that is nothing but what the oxide layers. Because these metals, when we talk about, they are reacting with the different gases present in the environment, present in the air, in the presence of a moisture, and they are forming a different compounds. And this particular process, because in this particular process metals are lost in the metal articles, and that's why this is called as the corrosion, the metals corrosion. And that's why, to avoid this kind of a corrosion, metals are protected with the different layers. It may be a oil, it may be a varnishing it may be a oil paints or the grease. Various things can be used to cover the layer of a metal to avoid a contact with the moisture in the air. And one of the examples they have given over here is about the Statue of Liberty. The color of Statue of Liberty is changed. Its statue was made of copper, but now it looks green. Why? Because the copper carbonate has been formed on the particular statue. Further, next is what we have to study is an alloy. Alloy is a homogeneous mixture of two or more metals, or a homogeneous mixture of a metal with a non-metal is called alloy. Definition for the alloy: a homogeneous mixture of two or more metals, or a homogeneous mixture of metal with non-metal is called alloy. Alloys are made by mixing the constituent elements. For example, stainless steel utensils used at home are made of an alloy of iron and carbon. Means stainless steel contains iron and carbon. Along with that, chromium and nickels are also used to make stainless steel. The alloy bronze is formed from copper and tin. Further, they have given some more examples over here is of an alloys and some other, like Qutub Minar in Delhi, made about 1500 years ago. The pillar is lustrous even after so many years. This is because our ancestors have made it from an alloy. It's made with an alloy, and that's why the luster of that is still as it is. Further, a cheap variety of a stainless steel is made sometimes by using copper instead of costly nickel. You might have seen the vertical cracks in stainless steel vessels. The reason is this. So, this is all about the chapters metals and non-metals. Theory part we have completed, physical and chemical properties of the metals and non-metals. In the next part, we will discuss about the exercise of the chapter.